Alright, we're live a little bit early this time, so I'm just gonna sit here for a minute. Uh, Hope everybody had a good lunch. Enjoyed this little 3 hour break between live streams. Uh, yeah, we are talking about testing. There will be something official coming out, I'm sure, soon. Before the next class, I'm sure. We're trying to work out some kinks, exactly how everything's going to work. I don't think uh, anybody's going to fucking fail this year. I don't know of a way for us to do testing like that's not in person and make sure, you know, it's a quality grade. So we'll see. We'll see what comes up. I don't really have any details to share right this second. It will come up in the future, though. All right. So, our very first question that we're going to go over is without using any exceptions. Oh, excuse me. Whew. That waited till I got started. Without using any exceptions, generally the smallest aluminum conductor permitted to be connected in parallel is blank gauge. So connecting wires in parallel, that's has to do with whenever you need more power than you're willing to pull the wire size for. So let's say you needed 1500 kc mil of wire. Well, that's going to be a awful thing to pull. Like that's just it's going to be cost prohibitive to pull that much wire, that big of wire. It would be much easier to pull three 500 kc mils and get the same amount of amperage to the motor, but have it in three different wires in three different conduits running out there. Uh, all right, so all that being said, what's the smallest size aluminum that you can pull in parallel? Well, that is 1 aught. You're going to look that up by looking up parallel conductors. Conductors and parallel. I think it's actually going to be conductors and then parallel. And that should take you to somewhere in Article 300. Somewhere in Article 300 we'll have that 310, not 300. 310.10H1 is where we're going to be looking at that. And that will be looking up conductors in the back of the book and then in parallel. And then the aluminum part, you'll just read I think it's actually a table. They have a table there too. Uh, you'll read the little paragraph and it will detail, yes, this is the conductors in parallel requirement. All right. Which of the following tables provides the allowable ampacities of insulated conductors rated up to and including 2,000 volts? Okay. That's my time to start streaming alarm. I snoozed it instead of stopped it. Okay, so this is literally the title of table 310B 15B16. It's a table we've used. I explained it in depth last week. Yeah. This should have taken you, like, made you think, oh, that table that we used last week. When insulated conductors or cables are used where exposed to direct rays of the sun, they must be listed and marked as being sunlight resistant. I would look up conductors and sunlight resistance. To get that one, 310.10D. Or direct sunlight. Probably conductors direct sunlight is what I would look up for this one. I'm pulling up the. So 4 is conductors. Okay. So we're going to be in 310 for this whole lesson. Should be in 310 for this whole lesson. Absolutely. Conductors used for direct barrel applications are required to be identified for such use. Yeah, 100% of y'all got it. Like, this was a pretty straightforward question. 310.10F. So, I've misread this one yesterday. This one is saying if you're using number 12 and number 10 and number 6 in the same circuit, what ampacity do you mark that circuit as being? And that would be, you're going to have to use the lowest value, which would be the number 12. So that would be without getting too far into it, a 20 amp circuit is what you would call that. If you had number 10, 12, and 6 and the same length, like you just made joints using whatever pieces of wire that you had, you have to size it based on the smallest piece of wire. So if you're running conductors in parallel, they have to be the same conductor. Yeah, that's pretty straightforward. A neutral conductor rated at 0 to 2000 volts that carries only the unbalanced current from other conductors of the same circuit shall be required to be counted when applying the provisions of 310.15b3a. Okay, so if you look in this area, it's not 310.15b3a, but right around there, there is a paragraph. It is at 310.15b5a. So it's like right there. It's right next to it. And it tells you, it has a title, and it's neutral conductors. And it will, let me make sure, double check myself. Three 1015B5. So it is neutral conductors. It is titled neutral conductors, and that will take you right there. It is literally right next to the table 31015B3A. That might not be 100% true once we move to the 2020 code book, because things shift a little bit, but it'll still be at this same location. Just its physical location on the page might be a little bit different. Except as permitted elsewhere in the NEC, the minimum size copper conductor rated 0 to 2000 volts, according to Part 3 of Article 310, conductors for general use is, okay, the smallest size copper conductor that you can use actually in a building, like for current carrying uses. And that is going to be number 14. Number 18 and number 16 are more for signal wires. Number 14 is the smallest wire that you can use for like actual current carrying situations. And that's going to be in 310, I want to say 106. Yeah, 106A. 310.106 is, let's find it. is just the conductors article. Uh, and 310.106 covers stranded conductors, insulation on conductors, conductor materials, and the minimum sizing of conductors. And I would say I would look up conductors and then minimum size. Type XHHW has a maximum operating temperature of 75 degrees Celsius in a wet location and blank in a dry location. That is 90 degrees Celsius. So that's going to be 310.104A. There's a table that's like 5 pages long, and that will give you every single insulation type and its attributes, its operating temperatures and everything. In a wet location is 75 degrees C. You'll see that on that chart. And a dry location is 90 degrees C. But that's in general. Wet location approved wires, if they're used in a dry location, their temperature is 90. And if they're using a wet location, it's 75. Unless they have the -2. So THHW-2 is 90 degrees across the board. I will talk to you later. One of the principal determinants of a conductor operating temperature is that the thermal insulation that covers or surrounds the conductor affects the rate of heat dissipation. And this is just general knowledge. I don't know where this would... Is it in the book? No, it's not. Okay. Basically, how they determine the temperature rating for a conductor is how well it dissipates heat in the insulation. All right. So, next up is Lesson 5. Let's finish this one. Second year code. Sorry. All right. Next up is Lesson 5. Remember, in Lesson 5, there is some reading material on the Blended Learning website for you. All right. Good luck with Lesson 5, and I will see you guys again at 3:45.